Hello everyone. So this side Dr. Deepika Sharma. Today I'm going to discuss you about Python Pandas library is very important data science library. So today let's learn in detail how to work with Python Pandas. So let's see how to work in Pandas. So first of all, we should know that what is basics of Pandas. So basically, Pandas is an open source Python package that is most widely used for data science and data analysis purpose. We do use Pandas heavily for the machine learning task as well. Pandas is a software library written for Python programming language that is used for data manipulation and data analysis purpose. Python Pandas offers data structures and operations for manipulating numerical tables as well. So today I'm going to do sales analysis by using Python Pandas here. Sales analysis using Pandas. Okay, so here I'm just making it. I'm making it a heading now. Click on OK. Click on Run button. Now, for doing the sales analysis, I need certain sales data. For that sales data, I'm having files present inside my GitHub repository. So these are the present files such as sales data January, sales data February, CSV files are present here. If I'm going to click it here, sales data January here, so we can see that there are certain columns present inside the sales data uh, January file here, such as order ID, product, quantity ordered, price ordered, and purchase address as well. So we will be using this particular file and we will be using all this column for our sales analysis purpose. Okay, so for sales analysis now, I'm requiring the data. So here I'm going to load this particular file. So here I'm going to call the sales data January.csv file, which is present inside my Jupyter notebook. So here I'm going to load it. Whenever I need to load any data from Pandas, I will be using a read CSV method here. Okay, so before that, what I'll do, I'm going to import Pandas file here. Import Pandas as PD. Once I'll just load it, I can use read CSV method to load Pandas file here. So here I'm going to use it. DS, I'm making a variable. It is a data source which will be holding the data file. So here I'm using a Pandas read CSV method here, where my sales data January.csv file will be loaded here. So here I'm going to call this sales data January.csv file. I'm going to load it. Now we should be aware that when we are going to load this CSV file, the separation of the columns are provided with the help of comma. So if I click it here and if I click it here onto the raw, so I will be getting this file. We should be aware that whenever we are loading this file, all the commas are all the columns are separated with the help of comma. You can see here various commas are present here, comma, comma. Commas are basically separators for individual columns inside the CSV file. So whenever we are going to load any CSV file inside Pandas, so there is one of the option present here inside this loading time here that I can use one of the parameters separator. So if I'm using the separator here, I'm just providing comma is a separator here. Comma is a separator of individual columns. So we are instructing here to Pandas at the time of loading that separator is basically comma. So if I'm using it, still my file will be loaded inside the variable data set. Okay. And if I'm not using this separator, then also my file will be loaded inside the data set, DS variable. So what does it mean actually? This separator is an optional. It means if I'm using the same structure here and here, I'm just skipping this part, since by default, this file will be loaded inside the variable ds because comma separator value itself means that all the separators are comma separations there. So even we can write this separator or we cannot write this separator parameter. Both are readable, both are valid here. Okay, so it just shows you, separator shows you that what is the separation point between the individual column here. Just to think it, suppose for an example, suppose right now what is happening, uh, by default here, by default, uh, commas are separation in between. One can see it here, comma, comma, comma. So it means commas are the separation in between. So whenever we are writing read CSV, so automatically read CSV means that we are reading the comma separator value file and all the columns are separated with the help of comma. So this one's a comma, column number C1, column number C2, column number C3. So these are three columns here. So these are separations provided here. Second thing, so in case, suppose my file which is loaded here that does not have the comma separation, that has semicolon separations. Semicolon separations. It means individual columns are separated with a semicolon, not commas. So in that case, I need to change the separator here. So whenever I'm loading the file, in that case, I will just say my separator is semicolon. That is not comma, that one is a semicolon. Okay, so how my syntax will be changed here? In that particular case, my syntax will be changed. Here, I need to write here separator is equal to semicolon because think that my file does not hold comma, that is holding semicolon as a separator. So it means I need to make understand this Jupyter notebook that I am going to load a file which is having separator as a semicolon. So this will be executed in that case. Okay. So the point is here that when we load a file, we do consider that all the data are separated with the help of comma. So that's why we are writing here comma is a separator. Even if we won't write it, still it will execute because default is comma separation. But in case whenever I'm just using semicolon here, suppose any file do have a semicolon, so there explicitly I need to mention my separator is comma separation here, right? So in that case, we need to consider this separator here. Now, so this is a way to load the file. So I'm going to use the read CSV method to load the file. Now let's take another case. Suppose here I'm having a file which is written in Excel mode. Right now, I had just given a file in CSV mode. If I'm going to load any file from Excel sheet, so I will just write here pd dot read Excel method here. So with the help of read Excel method, I will just give the file name file.csv. So it will start loading that file which is into the Excel sheet. But right now we do not have it, so we can eliminate it. So what I'll write it here, I'm just making it away. I'm not loading any read CXL file, but here I'm just conveying that how to load any file. So here I had loaded the data, read CSV, okay. And with the help of read CSV method of Pandas, I had loaded this sales data january.csv file inside the DS variable. So when I had just clicked it, I had written here DS. So it is just showing me this variable details entirely, that order ID, product, quantity ordered, price, order date, and purchase addresses. These are all columns presented inside this particular DS variable, which is holding sales data January CSV files details here, right? Fine. So let's move ahead now. Now, if right now, I had just loaded this file here. Now what I'll do, I'm going to use certain data structures of pandas. Basically, you should be aware that inside Python pandas, we do have basic two data structures. Two data structure is, one is series, another one is a data frame. When we talk about the series work with one-dimensional data structure. And when we talk about the data frame works with two-dimensional data structure. Two-dimensional data structures means we can load the data in rows and column format here. So what I'll do it here, I'm going to use the pandas data frame here so that I can work with various methods present inside that data frame, data structure inside the pandas, because it will help me to assist or to explore the entire data. That will help me to assist entire data analysis. So I'm going to use that data frame now. So I'm going to load this data structure, this DS variable inside the pandas data frame. So here I'm going to load it now. So I'm just making a variable here, dfjan. Why I'm making a dfjan? Because I'm loading the January data here. Okay, entire details of January. So the same DS variable is holding sales data January.csv file. So that's why I'm going to make here dfjan as a variable, as a data frame variable to load this data. So here I'm going to use it, pandas dot data frame. Here I'm going to use it. I'm just loading this DS. So inside pandas.data frame, there is a data parameter where I need to give what is the data source. So here I'm saying DS is a data source where the entire data is loaded. So I'm just calling it here. Now let me check it out, the entire detail of dfjan. So dfjan means data frame January details. So it is just showing me that order ID, product, quantity order, price, order date, and purchase addresses. These are certain columns presented here. Now there are certain methods and attributes present inside this data frame. So let me check it out. Right now it is showing 279 rows and 6 columns are present inside this dfjan data frame. Directly also I can use one of the attribute of data frame here, dfjan.shape. Shape will tell me that how many rows and how many columns are present here. So dfjan.shape, it is showing me 279 rows and 6 columns are present inside this data set here. Okay. So it is going to show me the shapes of the data. So whenever we need to check it out, how many rows and columns are there, I can just write there dfjan or the data frame name dot shape there. Now let's do certain very simple data analysis for this particular data frame, this particular file here, January data CSV file here. So there are certain predefined methods present inside this data frame. Now I'm going to use this. So I'm going to use dfjan dot head. Head method will show me here top five rows from the given data set here. So one can see it here. It is just showing you top 5 rows, 0, 1, 2, 3, 4. So from top to top 5 rows, it is going to show me. Now here, if I want to see bottom 5 rows, so I will just use here dfjan dot tail. So with this one, I can just see here bottom 5 rows. So you can see here 278, 277, 276, 275, and 274. So this tail method will show you bottom 5 rows here. Okay, so as we are doing the data analysis here, so we are going to use this. Now, suppose I want to see any row in between. So simply I'll write here the data frame name dfjan.sample. So when I'm going to use the sample here, so if I'm running it here, this dfjan.sample command will show me any row in between. Any row means any row it will be showing me. Such like it has chosen 151 here, so any row could be chosen here. Now, suppose I want to see any sample from in between. Any rows could be selected, but the number of rows should be 3. So what I'll do it here, df jan means I will be using the data frame name dot sample. Inside it I would be using 3. 3 means here I'm passing one parameter. 3 means I want to see 3 rows in between. So here I'm going to use it here, 3 rows in between. So here it is going to show me random rows, any 3 random rows in between here. Okay. So it means whenever I want to do a basic data analysis of uh, Pandas file. So I would be using the data frame methods here, such as loading of the data here. I'm going to do it with the help of data frame. I can use the shape method of data frame, where I can see the rows and columns. I can use the head method. With the head method, I can see the top 5 rows. With the tail method, I can see bottom 5 rows. With the sample method, I can see any row, any row. So, and if I want to see 3 or 4 samples, just I can pass the total number of rows I want to see it inside the sample. Okay. The same one I can do, suppose right now, head is there. I want to see 10, top 10 rows. So what I'll do it here, when I'm just writing it here, let me insert one row here, df jan dot head. So inside it, I can just write 10. 10, if I'm writing here 10 as a parameter, it will start showing me top 10 rows, 0 to 9. So it means it is showing me top 10 rows here. So the point is here that head by default takes top 5 rows and tail by default takes bottom 5 rows. But if you want to see with certain another number of rows, you can give dfjan dot tail 10. So it will be showing you bottom 10 rows. Now dfjan dot sample, it will be showing you any row in between. Okay. Now let's do certain more exploration of the data. Suppose here I want to see what are the column names here. So it is just showing you, this command is showing you order ID, product, quantity order, price, order date, and purchase addresses are basically your columns here. So it is also showing you data type is equal to object. It means that your data are present into the form of string. String data, they are presented here. That's why it is just showing to you. So currently we are going to look here that there are 1, 2, 3, 4, 5, 6 columns are present here. And it is these commands are just showing me entire number of columns. Suppose I want to see individual columns. I do not want to see entire number of columns. So simply I will just call that particular column that I want to see. Suppose only product I want to see, this product I want to see it here. So same spelling I would be taking it here, that just show me only product. So here it is going to show you the entire product details, all 279 rows for only product column, not entire. So we can select a particular column whenever I want to see it. Suppose here I want to see here what are the purchase address. So what I'll write it here, df jan, and here I want to see the purchase address. So I'll just write it here, purchase address. Here I'm going to call it purchase address. So it is going to show me entire purchase addresses, entire state, city, pin codes, everything is available into the purchase address. So this one is, it is going to show me. Okay. So in this way I can see it here. Now, suppose here I want to see here product and price, this product, and What is the product name? What is the price each here? So I can just see two column as well collectively. So here I need to write it double time here. So here, comma, and then here in this way. Wait. Just a moment. Comma this way. So here I would be writing the first product. Here I'm going to use the second column. This column one, column two. So here I'm going to take product, the same product I want to see, corresponding its price. So why I'm using that one? So that there should be no spelling mistake here in any case. I want to see this price. So I'm just taking this price each column. Same column name, I need to write it here. So price each. So it is going to show me product as well as price. Okay, so the product and the price also, we can see it here. Now suppose here, I want to see that inside this entire table or entire data set, is there any missing data? Is there any null data? Can I see that? Yes, we can see that. I can just write here df jan dot is null. Is null is a command which will be assisting me that there is any missing data, null data are present or not. So currently, whenever false values are coming, it means there is no missing data here. But what is happening actually, it is just showing me because we are having a lack of space. Right now, it is just showing me certain top and the bottom one. But still there are a lot of rows in between because we are having a space, no so much space present into the Jupyter right now here while displaying. So it is not showing me the entire other nearby 200 rows as well. So what I can do, I can use the same command with sum so that with the help of that this command, I can make a sum of entire number of rows through which I can just check it out whether is there any null data, is there any missing data present inside this data set. For that confirmation, I will just write the data frame name tfjan dot is null dot sum method. With the help of it, I can find the entire sum of these different columns. So here it is showing, I want to see, is there a, just show me the sum of any null data. It is just showing me zero. It is showing no. Inside your data set, there is no missing data. There is, everything is fine. There's zero missing data. It means your data are okay. There's no problem with your data. Everything is okay. There is no missing data present inside it. Okay. Now let me tell you one thing. You think it, for example, let's consider, suppose we got suppose three rows missing or two rows missing or one row missing. Let's consider, let's assume this case. So what I can do if this happens, I can use a simple command here. Okay, what is that command? Simply I will use here data frame name dot drop na. Drop na. If I use it, it will drop all the rows. This will drop all the rows which are missing data. So drop na is a command inside the data frame which will be dropping the number of rows those are having missing data, null values. But currently we do not need it here. So what I'll do it here, there's no need to write this command because there's no missing data, but this is just for the information purposes. Okay, so I can even remove it here. Fine. Now let me check it out the data here. Okay, so right now we do not have any missing data, so entire data are there. Now suppose I want to see product column or order date column here. So basically you should be aware that inside Pandas, we do have methods to do certain indexing and slicing. Okay, indexing and slicing. Let's talk about that indexing. Indexing means here, if I want to select a particular column with a specific number of rows, that I can do it with the help of indexing or slicing. So inside Pandas data frame, there are two methods provided to do the indexing and slicing. One is lock, another one is ilock. Lock is a label-based data. So whenever I'm going to use the lock command, where I can just use labeled data. Labeled data means whenever I need to select a particular column, there I can just use the name of that column. So what I'll do it here, let me show you how to write the lock command, lock. So here I will be just writing data frame name dot lock command. So lock command needs two things here, that how many rows you want to see and how many columns, which columns you want to see. So here I need to deliver two parameters here. So inside these two parameters, where I just provided this one, I need to provide that how many rows I needed and how many columns I want to see it here. So if I'm providing this range, this one is a range here. Range means just provide the entire data from start to end number of rows. And in columns also, you can provide start column and ending column details. So I can write the start end of the rows, start row number and the end row number of the rows. And in columns, I can just write here start and end rows, column names here, I can write it here. So whenever I'm using lock operation, inside the lock operation, I need the names of the column and names of the rows as well. For this, what I can do, suppose I want to see all the rows of product column. So what I'll write here, I'll just click it here. I will be using lock operation where I'm going to use colon. Colon means take all rows from starting to end. And which column you want to see? Here I need to give name of the column. So here I'm just giving product is the name of the column. I want to see the entire product uh, with colon means with all the rows. So if I'm writing it here, it is going to show me entire number of rows with product column. Okay. Suppose there is a order date. I want to see what are the order dates. So this I can take it and I can put it here in the column name here. So I will just write here dfjan dot lock operation, and inside the lock operation, I would be writing here order date, that I want to see all the rows of order date column. So lock operation will take the name of the column during the indexing. So this first parameter, it is showing me that show me all the rows from starting to end of order date column. So if I'm seeing it here, it is going to show me the entire number of rows with order date column. Okay, so now let's move ahead after looking the order date. And we can see one more thing. Inside this order date, we are having the date as well as time. So this one is a time and this one is a date. So we can see the date as well as time inside this order date. So both things are present here. Okay. Now let's see, suppose I want to use another method of data frame to do indexings here. Suppose here I want to see these data, any of these columns. So whenever I'm going to use another method of data frame indexing, so there is an ilock operation. Ilock operation means index location operation. See, earlier when I used the lock operation needs the names of the columns. But in ilock operation, it does not need any name of the operation. So whenever I'm using the ilock operation, simply I need to give the indexings of those columns. So here I need to give the rows details, that how many row starting row and the ending row detail I want to give it here. And here into the second parameter where I need to give the details of the columns. So here I need to give what is the starting and what is the ending of the column. But there is one benefit of using iLock. I can give here index location. Index location means by default, all these columns are indexed, such as 0, 1, 2, 3, 4, 5. So simply if I want to see product and quantity order, so here I will just give into the column 1, 2, 3. So it will start from 1 index, move up to 3. But do not involve 3. 3 is exclusive. So here it will just count 1 and 2. So here I'll be taking 1 and 2. So here I'm going to use the same one here. So what I'll write here, df jan dot ilock operation, index location operation here. I'm going to give it here. Show me all the rows with 1, 2, 3 column here. So 1, 2, 3. So it means it is going to take 1 and 2 column here. So 1 and 2 column, it is going to show me product and quantity ordered. Suppose here I want to see zeroth column only. So which one is the zeroth column? That one is an order ID, because these are just indexed in this way: 0, 1, 2, 3, 4, 5. So these are the basic indexes provided here. So order ID, if I want to take it, so this one I can take it here. So what should I write it here? df can I want to see ilock, so ilock operation, and here I need to give it colon, show me a zeroth operation here. So here it is just showing me order ID. Suppose here I'm writing, show me the first column. So here it is going to show me product detail. Suppose here I want to see here 2th column. So here I can just click it. Here it is going to show me quantity order. These are quantity order. You can see it here. Suppose here I'm writing, show me the third column here. So iLock operation, so it is just going to show you price. And if I'm writing it here 4, so here it is going to show you, wait just a moment. Now it is okay. Here it is going to show you order date. So basically, whenever we are doing the index location operation, there we need to give only index. And here, suppose I want to write here, show me 1, 2, 4. So here it is going to show you 1, 2, 3 index details. 1, 2, 3 index details. So 1, 2, 3 means product, quantity ordered, price details it will be shown. So we can use iLock operation in this way. Index values I can get it here. Okay. Now let's see here. So we did the entire work with January sales. Now what I'll do, I'm going to load the other file. That one is a February sales data. So let's load that file here. So I'm making a data frame here where I'm going to load the February file here. This file is also present here into the GitHub. You can see it here. Sales data February.csv file. This one is also having same column name, but this is the file related with February sales. These are the same columns. We can do this entire same analysis for the same file: order ID, product, quantity order, price, order date, purchase address. All the same columns are present here, but these are February sales. Okay, so I can load the same file by going to raw, copying and pasting data entirely in Jupyter Notebook. So here I'm loading this file here, pd.read.csv method. I'm going to use it here, and here I'm going to use it sales. What's the sales data? Sales data February.csv file here. So when I'm going to load this file, I've loaded this file. Let me check it out, this file. This file has the same columns which I had used for the January data. So this one is just a February data. Same column names are there. And what is the shape of this one? Oh, this one is df dot shape. I can use it here. What I can do when I'm loading it here now. So this one is also basically data frame here. Okay. What shape it will work here. Oh, wait, just a moment. Is not defined. Actually it is saying this is not defined. It is saying df feb it is there, df feb. Oh, just it is showing you the same one. I want to see the shape here. So here it is showing you 410 rows and 6 columns are there. See one more thing here, that whenever we are loading this file with the help of read CSV, this one is also, you can call it a data frame here. This one is loaded here. Here, df feb.shape, it is saying 410 rows and 6 columns are present here. So total number of columns are same of January and February file, but rows are different. Does not matter. You can do the same data analysis like I did it here by using uh, head, tail, sample, that you can do it. Okay. And you can do the uh, lock operation and index location operation for doing the indexing and slicing inside the Panda with the same methodology like I had used it above. One can use that also. Fine. Now, what I can do here, uh, I want to, I want to make the two data concatenated. So concatenation means I want to add two data collectively, right? Because we do have number of rows, and those number of rows inside different data set have a same column. So columns are same, only rows difference are there. So the point is here, if one data frame holds, let's say 6 columns here, this one is a 1, 2, 3, 4, 5, 6 column. I'm going to take 6 column here. So this one is the data frame 1, let's say January data. And now I'm making a February data where I want to load this file together. It means the columns are same here, only rows difference are coming there. So it means I want to make these two added. These data frame January and data frame February added, so that we can create a one file. Okay, one sales file. How can I do that? For that, I can use a pandas concat operation. Inside the pandas, we do have concatenation operation, which will be assisting us to make the entire data collected in a one source file. So what I can do, I can take the help utility to find out pandas concatenation function here. If I'm taking this help utility, it is just showing me uh, concat module is present here. Concatenation, uh, concatenate function of pandas objects along a particular axis with optional set login. What does it mean actually? It is just saying that we are having pandas concatenation operation. This one is the operation where we can provide the two data frames and we can merge the two data frames collectively. Okay, so here we can pass on two different data frame objects, and once they are passed, the entire data of those columns and the rows are collectively fixed together. They are added actually. So let's do it. And here we can just give that along with axis 0. Means here I want to add data frame January and data frame February along with rows. So there is one of the parameter inside the concatenate that I can join the data along with rows. So I can just put it here just by writing axis equals to 0. It means join the entire data along with rows, along with indexes here, along with rows. Okay, so default value is 0. It means if I'm using a concatenation operation, it will automatically glue the entire January data and February data along with rows. Okay, default 0 means along with rows, it will be gluing the entire data. So that I can use that. So I can read whenever I feel to read any details of any function, I will be using the help utility. Okay, so now what I'll do it here. I'm going to use it here, Pandas concatenation operation, where I'm going to use the two data frame to glue together along with the rows. So that I'm going to use now here. So here I'm going to do it. I'm making a variable all df is equal to pandas dot concat. So inside the pandas concatenation operation, I can just glue two data. So df jan, this one is a df jan. I will take this name as well as I will be taking df feb. So here I'm going to take it. Here I'm going to take data frame jan. Just glue this entire data with df feb by using concatenation operation and automatically kindly glue it along with axis 0 means along row wise just to add the entire data. With this one, I will be gluing the entire data. There's one more parameter needs to be settled, ignore index, so that it can just make the index default with 0, 1, 2 up to n number of rows here. Otherwise, it will restart the index from data frame 1 and data frame 2. So just to avoid it, I'm just writing this parameter. Ignore index is equal to true will make the entire index means row number from 0 to n number. So that I'm going to do it here. So, okay. Okay, the command is successful here. So let me see whether the data are glued together in a form of rows here because columns are same. Okay. So it is here running here, order IT, product, everything is same here. Oh, can you see here 689 rows are there and 6 columns. So it means nearby 300 rows are coming from data frame January and the remaining 400 I feel rows approximately they are coming from data frame February. So the all entire rows are glued together with the help of concatenation operation where it says kindly concat or add the entire number of rows of data frame Jan and data frame Feb along with the rows. Okay, along with the rows just to add the entire data. And you can see it here, the entire data has been just glued together. So nearby 700 rows with 6 column approximately we do have it here. So in this way, students, whenever we need to add two data frame and those data frame must be having the same columns. So we can concatenate the two data together. We can concatenate the two data collectively with the help of pandas concatenate command here, right? So in this way, we can do this concatenation operation. In the similar way, I'm having one more file, sales data march.csv. So I will be loading the same data here with a df march here, where I can load the March file data. So that one is also loaded here. So let me load this file here. So here, this file is loaded and let me check it out df March here. So it is also having the data with same column, but this one is a March sales. Okay, so sales of March data. So what I'll do it here, I want to merge this data also. Same data I want to merge it here, right? So what I will do here, when I'll be merging it here, I'll just write here all df. See, I'm updating this variable, so I'm using pd dot concat. Same operation I'm going to use it. I'm going to take earlier all data frame which I had created earlier, this data, but I'm updating it. This data I had created, which is holding 689 rows of January and February. I'm going to merge it here with the March also. So here I'm going to use df March, and here I'm going to glue it with along with rows with axis 0. This one is the default value. Even if you are not writing it, does not matter. Ignore index because it should not restart the index with new data frame. Okay, and here I need to give it index true is equal to true value. Done. Done. Once it is done here, so let me run it. So I had just made it for the same one because I need to update all data frame here. Oh wait, so this one is there. Now you can see it here, 924 rows with 6 columns. So it means I had merged a 3-month data here, okay, with the help of concatenation operation. Up to here it is okay now. Okay, so now what we will be doing here, now my file is ready with nearby 924 rows and 6 columns. All data frame is having 924 rows and 6 columns. I want to save this data into the form of CSV file. So here, how to use it? I'll just use certain commands here. All df dot to CSV method, I will just use it. All df means entire data, hold the entire data with to CSV method. It means kindly store this entire data frame data in CSV format. So to CSV, so this data will be moved inside a CSV file with the provided name. You can find it in your home directory. In home directory, you can find it out. So here I'm just providing, kindly save this entire data frame where 924 rows and 6 columns are present with the names of sales modified 1 dot CSV. Okay. So sales modified 1 dot CSV. So this file is loaded there. Okay. You can give any other name also, but this file you can find it out inside this one, uh, home directory, where your current Jupyter is running. I'm just giving one more parameter, index is equal to false, so that it cannot take any extra default index columns automatically. So index is equal to false, kindly do not make any other index column here. Okay. So once this is running here, so one can say sales modified 1.csv inside the home directory, it is created. Now what I'll do, I will be loading the same file from the Jupyter notebook. So let's see how to load it again. So I will be using the pd.read CSV method here. So I can use the same one. If you want to see the details, you can write a help pd.read CSV, and you can read the entire details of read CSV method, that how we can load any file, and that I did it in the beginning also, how to load the files here. So whenever you want to read the entire details, you can use the help utility functions there, right? So here I'm going to use the sales modify 1.csv. I'm going to load this file here. So simply I'll just write here sales df is equal to pd dot read CSV, where I can just use the same one, the same name I need to load it here, this one. There should be no change into the name. Same name should be called here in the read CSV method here. Okay, and let's load it here. So I reload it back, sales modified.csv. Let me check it out, the sales TF here. I had just loaded it here. Wait, the same sales TF I had loaded back. So remember, read CSV method will read the data from the Jupyter notebook. To CSV method will store the data frame inside the CSV file in Jupyter notebook. So again, same data I'm going to see it here. Now, let me check it out whether there are missing data among this 924 rows here. So I will just write here sales TF dot is null dot sum. So here I'm going to see it here. It is just showing me three rows are missing in every column here. So maybe in sales March or sales March or sales February, somewhere data are missing. So it is just showing three rows are missing here. Now, if I want to drop this row, I will be using this pandas method here. Sales data frame, kindly drop missing data. Drop NA means drop null values. Drop missing data along with axis equals to 0. It means drop the null data along with rows. This is the default value. In place is equal to true. It means kindly drop this entire data in the same data frame sales df along with rows. Okay, it is dropped now. If I want to check it again, the same line, if I want to give it here, let me check it out because the data are dropped now. If I'm giving the same line here where the data are missing, still missing, it is saying no. There is no missing data. Zero missing is there because we dropped it. So access equal to 0 means drop the entire data which is null, drop those rows along with which are null data in the same data frame. In place is equal to true means make the changes into the original sales data frame. Okay, otherwise we need to store that this changes into the another data frame that we need to make it here. Now if I want to check it out, what is the shape here? Sales df, because three rows has been dropped, so that's why shape has been changed. Shape is little bit changed here. 921 rows and 6 columns are there. Now, we know that there is one of the column here, order date. Inside this order date, there is a date and time together. If I want to make a split of this date and time separately, so what I can do, I can use pandas dot to date time. To date time, where I can just extract date and time differently. Okay, so we are having that one. So I'm using that one here, sales df date and time method, through which I can load the data separately for the date here. So here I'm going to use it, a command. I'm just using here pandas dot to date time is there. To date time means here it is going to show you that kindly extract the date from order date. Kindly extract date from order date here. Okay, and to extract the data for the date, to date time method will be assisting us inside the pandas here. Okay, the same I can use it for time extraction also, that from this order date kindly extract the time also. So for that, what I can do it here, for that I can extract the time. So if I'm running it here, it has extracted the date, and the same one if I want to do for the time, I'm just saying here that kindly extract the time from this order date. So inside the pandas, there is a date time library which will be assisting me to fetch out the data of time from the order date. So once I will execute it here, it has extracted the date and time separately from order date with the help of to date time. If I'm looking the same one, you can see it here. Date and time columns are created from this order date. So these dates are extracted separately and these times are extracted separately just with the help of pandas date time here library. So it will help me to extract the data here, right? Now here inside this date, we are having month also, such as 1 month, 2 month. Can you see a 1 month, 3 month? Can you see a month? Months are there, month, and these months are there. I want to take out only month part from this date, only month part from this date. Again, I would be using date time library to extract the date time library to extract the month from this particular date, this particular date column. So here I'm going to use it. So this one is sales DF. If I'm checking it out, sales DF, I can see here. You can see here, see this one sales DF. I'm going to check it out. You can see there's a month separately created. A month is separately here created. This one is the first month detail, this one is the third month detail, and in between there is a second month detail, means January, February, March detail. So we can extract the month from the provided date as well. So we can extract all these things. Okay. You can do the same one if you want to have the analysis, salesdf.tail, salesdf dot sample, you can take it, salesdf dot uh, uh, tail, you can do that, salesdf dot tail, you can see it here. So see here, you can see third month is given, March is coming here. If you're writing here sales df dot sample, you can see it here. So here it will be taking any sample in between, any first month it is going to give to you. Now the point is here, because there are 3 months details are provided, it means January, February and March details are provided. I want to see how many rows are provided to January month, how many rows are provided to February month, how many rows are provided to March month here in this entire 900 number of rows. So here I can see that with the help of count, value count functions of data frame here. So simply I can write it here, month, but inside that month, I want to see what are the value counts. So value counts will be assisting me that here 404 rows are provided to February, 279 rows are provided to January, 238 rows are provided to March month here. So total number of rows are provided to these different months here. Now, suppose I want to understand that among these entire um, I want to see that among this entire 900 rows approximately, how much quantity is ordered, how many rows. I want to see how many rows are present for one quantity, how many rows are present for two quantity ordered, how many rows are present for three quantity, fourth quantity, or five. So I can use the same one here. Simply I will just write sales DF, and here I can just give quantity ordered, that I want to see what are the quantity ordered. So same one I can use it here, that what are the different quantity ordered. Okay, and how many rows are provided to this one. So from there, we'll be generating certain ideas. So here it is saying 838 rows are provided to one quantity ordered, 59 rows are present for two quantity ordered, 19 rows are present to three quantity ordered. Okay, and the remaining one are there. So in this way, we can see the value counts here. Now, as you know, from this order date, right now, date and time has been extracted. Date, time, and month has been extracted. So now this order date, I can drop it because there is no use of this order date. So whenever I need to drop any column such as order date, so what I can write it here, I can just write it here, sales df dot drop. And here, if I want to drop this order date, this order date. So I can give here, drop this order date along with axis equals to 1. Axis equals to 1 means drop this order date along with columns, make the changes into the original original data frame here. Once I'm going to do this, so here order date has been dropped. If I'm checking it out, sales TF here, so you can see it here completely. Order date is not present here, only order ID, product, quantity order, price, purchase, date, time, and month is there. There's no presence of order date present here. Okay, so axis equals to 1 means drop the column along. Drop this order date along with the column. Axis equals to 1, column wise drop is there. Right here. Now I want to extract from this purchase address. Suppose purchase address, I'm going to use it. I want to extract the details of city and state, that which city and which state people are buying this product, that I want to understand. Not, I do not need this house address around, no. So this from this purchase of address, I want to find it out. So what I'll do for that, I created a specific function here, user defined function. I had created it here separately so that my um, I can extract city and state, and I can make city and state. I can make city and state separate uh, columns as well inside this file, so that I can do that. So I created it. So now it is showing me, once I created it here, this entire user defined function, I created it here. So it is going to show me that we had abstracted your uh, cities as well as state in a separate column here. So I had just used that one. Okay. So once it is there, then I can see the sales TF. So if I'm checking it out, the sales TF here, you can see here order ID, product, quantity order, price, purchase address, date, time, month, city, and state is also present here. So I had just extracted the entire details here. Is it okay? Fine. So these are there. So in this way, we can extract the data, right? Now, because the purchase address, I had used it, I had extracted the city and state, so I can drop it here. So let's learn how to drop it here. So simply, I will just use the drop function here. I will be using the drop function here, where I can just drop the purchase address along with the column. I can do that. So access equals to 1 means drop the data along with the column in a same data frame. So I had just dropped it, and if I can want to see it here, so here it is going to show me here. You can see it here, only date, time, month, city, and state is there. There is no purchase address that has been dropped because there is no use now. We had extracted the data, right? So in this way, I can extract the data. Now what I can do, if suppose this is an entirely changed data now, changed data frame. If I want to store this data, how can I change it? How can I store it? For that, I can use toCSV method to store this data. So how to store it? I can just use toCSV method where I can just say new sales modified one.csv. So I can just write it here, sales data frame dot to CSV method whenever I want to store this data frame. New sales modified one.csv file. This file should be saved. Okay. And here I'll just write here index is equal to false. So I just save this file, this entire data frame with the new sales modified one.csv, right? And here I'm just done it. If I want to, because you can find it out, this file inside the home directory here, you can find it out where your Jupyter is loaded. Once it is done, then here I want to reload it back. So simply what I'll write it here, I'll just write a new sales variable. I can make it new sales data frame here is equal to pd dot read csv method here. I'm going to call the same file. You can see it here. Same file. I'm going to call it here. Here. I need to quotes. I need to put it quotes. The same file should be called it here. Done. And I can load this file here. So just let me tell you how. So new sales df. I'm going to load it here. Oh, okay, it is not executed. Wait, okay, just wait. Variable is not defined. This one is there, so I loaded the same file, new sales modified.csv, where this data is present here, right? So that I want. Okay, so now let's move ahead a quick data exploration because we did entire data analysis with the help of pandas. Now I want to do certain data exploration just to understand that suppose I want to understand that from this data, I want to make analysis that what was the best month for sales, in which month, like January, February, or March. Among these 3 months, which particular month has the best sales and how much that particular month earned. So that I want to see it here. Okay, so I want to make these exploration. So data exploration, I want to make it here. So for that I need to make the calculation here. So here I just created certain data here. New sales data frame. There I want to find out sales. So what I'll do, I'll just find out the quantity order. Okay. And I'm going to make that multiplication of quantity ordered into price. Okay. So that I'm going to do. So I'm making the multiplication of that. What is the quantity ordered and what is the price each of those quantity, and I'm just making that one entirely into the new column sales here, so that I can see that which month is having the best sales. So this one is there. So if I'm writing here new sales TF, because that one is having additional sales column here. So here it is just showing me, wait, here it is going to show me these are the sales. Can you see these sales are there? Sales here, sales here, sales are provided here, where I had just multiply quantity ordered with price each. So these sales are present here, but I want to see these sales as per January month, February month, and March month, means different month here. So what I'll do it here, I'm going to use certain queries here inside the pandas. There are certain pandas SQL queries are there. So what I can do it here, I can just write it here. New sales DF dot group by month. I want to see the entire details with grouping by month, and I want to see that there's sum here. So here it is showing certain data. Can you see here month, January, February, March month is there. You can see the sales here. Sales is going highest in 64,000 something dollars. So it means in February month, highest sales are there. If I want to plot the same data, so I will be using a very important library in the world of data science. That one is a matplotlib. So I'm going to use this matplotlib where I'm going to pass the same data where I want to see that which month has the highest sales. So that also I can do it here. So first of all, I need to import matplotlib, and there I need to write certain commands which are related with matplotlib. Here it is just showing me that highest sale is going into the month of February. So February is having the highest sales here. Okay. So this I'm going to understand here. February month has achieved the highest sales here, right? Suppose here I want to understand that suppose I'm having a question here that which city sold the most product, which among the city which has sold the most product, that I want to understand. So here simply I would be making the grouping of cities here. So simply I'm using new sales group by city.sum here. It means just show me make the group of the cities and start showing me the sum. From there also I will be just having an idea. So here it is showing city names, Atlanta, Austin, Boston, different city names and their corresponding sales here. So one can see these two data, city and sales data, and one can see it here that which particular city has generated the highest data. From here, it is just saying San Francisco has generated the highest sales here. Okay, if the same one, I want to make a plotting here with a matplotlib. So there is a very important library. Just now I told you for the matplotlib. This one. So here I can just give few commands on the matplotlib through which I can just generate the data that which particular city has made the highest sale. So here it is just giving you San Francisco is the particular city which has made the highest sale. Okay. So in this way, I can make a small data analysis through which I can just understand that how a particular data analysis can be done here, right? So we can extend this sales analysis also with more work of the pandas here. Okay, so in this way we can make certain small queries where we can think it that here how to do basic sales analysis. We can do it with the help of pandas. So basically pandas assist us for the data analysis entirely. We can do it by loading the data sets. We can have any kind of data set. We can use pandas heavily. Okay, so pandas is very important data science library here. So today I just covered that how to work with pandas data analysis entirely. Okay. So hopeful that you had learned a lot during this session, and maybe I feel it that you had enjoyed the session as well.